All right, 9.7. So 9.7, we're going to be talking about the exponential growth rate first, and then we'll talk about the exponential decay rate. Okay, so this is the exponential growth rate formula. Okay, where P of T is going to be the end amount. P sub 0 is going to be the beginning amount. K is going to be your growth rate. And then the T is going to be the number of years since the beginning amount. Okay, so let's look at number 1. Number 1 says in 2012, the population of a city was 5.43 million. The exponential growth rate was 2.11% per year. Find the exponential growth function. So we're going to fill in everything we know in this function. Okay, so in the blank, it's going to tell me you're finding P of T. So in this position, I need to know the beginning amount. Well, in the beginning amount, the year was 2012. The beginning amount of the population was 5.43 million. So your beginning amount is 5.43. Then your E to the K times T. Well, my K is the growth rate, which is 2.11%. But remember, when we put it in the formula, we always want to put that not in percentage form. We always want to move the decimal 2 places to the left. So my K is going to be 0.0211. The T is what I do not know. The T is what I'm going to constantly be changing depending on what year it is. So here's my exponential growth formula. Now, the next part is saying the population of the city in 2018. What is the population? So what is the T that I'm going to use? How long has it been? 6 years. So I'm finding P of 6. I'm replacing the T, which is the number of years, with 6. So let's see, I've got 5.43 E to the 0.0211 times 6. And you will put exactly this right here in your calculator. So 5.43 E, and remember where your E is. You'll hit your second button and then your LN button to get to E. It goes right up into your exponent, and in your exponent you put 0.0211, open parentheses 6, close, and we're going to round it to 1 decimal place. And it tells me 6.16. If we're rounding it to 1 decimal place, what does this need to be? 6.2, right? I'm rounding up since the next number is 5 or greater. So 6.2 million is what the population will be in 2018, growing at this rate. The C part says the population of the city will be 8 million in about blank years after 2012. So let's see what I know with the formula. 8 million is what the ending population is going to be. So I do know that. What I don't know is T, right? So I do know the end amount. What is the end amount? 8 million. The beginning amount stays the same, right? It's always 5.43 million at the beginning. E, I do know the K, right? The K is the growth rate, so 0.0211. The T is what I'm looking for. The number of years after 2012. So let's see. What I'm solving for is in the exponent. So at some point, I am going to have to ln both sides, right? That's what brings exponents down in front. But before I do that, let's get rid of the 5.43. So I'm trying to move all of this over here to get that T by itself. So I'm going to divide by 5.43. So I can get everything over here. And then at the very end, I'll just put all that's over here in my calculator. So I canceled out the 5.43. So now I have e to the 0.0211 t. Now I'm going to ln both sides. Because what is that happens when you ln both sides? Why would I do that? So now I can bring down my exponent. So now I'm going to have 0.0211 t times ln e. But what is ln e? 1, right? Anytime you see ln of e, it is equal to 1. So all I really have over here is 0.0211 t times 1, which means I don't really need that. So how do I get this t by itself? Divide by 0.0211. So now the t will be by itself. So I just need to put all this right here in my calculator. So be careful how you put it in. You're going to do ln of 8 over 5.43. Then go ahead and close that. That's telling it that you're done typing in that. And then you're going to divide by 0.0211. And so be careful on this section that you're always looking at what it wants you to round it to. It's different every time, I feel like. So this says round to 1 decimal, and it's 18.36. Which means 18.4. So it'll be 8 million. The population will be 8 million in 18.4 years after 2012. I just did ln, then 8 divided by 5.43. And after you type in ln, it automatically gives you an opening parenthesis. Close it after that 5.43. And then divide by 0.0211. The last part of number 1 says the doubling time is about blank years round to 1 decimal place. Okay, so let's see. The formula for doubling time always is if you know the growth rate, you can figure out how long it's going to take something to double. All you have to know is the growth rate. Your doubling time is going to be ln of 2 divided by your growth rate. So let's see, this one will be ln of 2 over, what is my growth rate as a decimal? 0.0211. And we're going to round this. So this is going to tell me how many years it's going to take the population to double from 5.43 to whatever double that is, if it's growing at 2.11%. So ln of 2, close it, and then divide that by 0.0211 and round it to one decimal place. So I got 32.85. So if I round that to one decimal place, it'll be 32.9. So if the population is growing at 2.11%, it's going to take it 32.9 years to double.
Where you find ln?
Oh yeah, ln 2.
I don't let me go back. Cause you're squaring here, right?
No, I'm not squaring it. I'm just
okay.
ln of 2.
Oh, okay, never mind. I thought you were squaring it.
Oh no. Oh, it doesn't look like that. Yeah. So ln of 2. Okay, number 2. Number 2 is going to give us a chart talking about country A and country B.
What section?
No.
All right, here's my chart. Country A's growth rate is 2.1%. What is going to be its doubling time? So the exact same formula that I used on that last question, doubling time is ln of 2 over the growth rate. Well, I know the growth rate is 2.1. Make sure you turn that into its decimal form, not percent. So move its decimal 2 places to the left. So it's going to be 0.021. We're going to round this doubling time to the nearest whole number. So ln of 2, close it, divide it by 0.021 equals rounding to the nearest whole number. So it's 33.0. So it'll be 32 years to double, growing at 2.1%. Now, what if you know the doubling time or how long it takes to double? That formula the growth rate is going to be ln of 2 over the time it took to double. So let's see, if I'm finding the growth rate, it's going to be ln of 2 over, how long is it taking it to double? 28 years. And then we're going to round this to the nearest 10th. So let's see, ln of 2, close it. Divide that by 28. So I have 0.0247. So if I'm turning this into a percentage, I need to move it 2 places to the right. So it's 2.47. But it only wants me to go 1 decimal. So 2.47 is going to round up to what? 2.5% is the growth rate if it doubles in 28 years. Right, number 3. Now, remember back, I can't remember exactly what section it is, 9 something, where we were talking about compounding interest, and it was either compounding quarterly, which meant 4 times a year, or semi-annually, which meant twice a year. And so that would be that formula had that N, which you replace with the number of times per year it's compounded. This is going to be the formula that we're going to use if it's compounded continuously. So if your money is compounded continuously, you're going to use this exponential growth formula. So let's see what this question says. Suppose that 11,674 is invested at an interest rate of 5.8%, compounded continuously. Find the exponential growth function. So what is P of T? So here's what I'm trying to find. P of T. Do I know the beginning amount? Remember, that's always the first, what's in front of the E is the beginning amount, which is, correct? 11,674. Then the E. I do know the K, right? I do know the growth rate. Don't forget to move it 2 places to the left. So what are you going to have? 0.058 T. So that's going to answer the A part of the question. This is the part that's going to give me the formula that I can now use for the next several parts, because now it's going to ask me the balance after 1 year is blank. After 2 years is blank. After 5 years is blank. And after 10 years is blank. So what am I replacing every single time? The number of years, which is T. So after 1 year, I'm finding P of 1. So 11,674 E to the 0.058 times 1. And then you just put that in your calculator, and we're going to round it 2 decimal places, or in other words, to its cents. So let's see, 11,674 E, so second ln. Up in my exponent, I have 0.058, and then I'm just going to open, put in the 1, and close, just like it says on the board. Then hit enter and round it to 2 decimals. So after that 0.11 is a 2, so I just don't need to round up. So 12,371 and 11 cents after 1 year. After 2 years. So what's the only thing I'm changing? The time from 1 to 2. And then just putting that in my calculator. So 11,674 E to the 0.058, open, 2, close, hit enter, Oops, that's not in. And again, round it to 2 decimals. So after the 85 cents is a 3. So I just don't need to round up. So after 2 years, I'll have $13,109.85. What about after 5 years? Again, all I'm changing is the T to a 5. I'm putting that in my calculator. So get 11,674 E to the 0.058 times 5. Rounding it to 2 decimals. So after the 45 cents is a 4. So again, I just don't need to round up. So after 5 years, I'll have $15,601.45. And the last one of this part. After 10 years. So 11,674 E to the 0.058 open 10 close. So that's going to give me $20,850.21. The last part of this question is how long before your money doubles? What's the doubling time? So is it going to be, so here's my beginning. After 10 years, I have this much. So is it going to be more or less than 10 years?
More.
It's going to be a little more, right? To double it. So let's see, doubling time, T equals ln of 2 over your growth rate. So it's going to be ln of 2. What's your growth rate? 0.058. Rounding it to 1 decimal. So ln of 2 divided by 0.058, rounding to 1 decimal. So after that 9 is a 5. So what am I rounding 11.95 up to? 12. So it takes 12 years to double, which is what we about what we expected, right? 10 years got us to 20,850. So just a little bit longer would double that. Okay, so that is the exponential growth model. But what if you're not growing, you're decaying or going the other way? The only thing that changes is that K now is going to be negative. So it's a negative growth rate or a decay rate to work these next problems. All right, the data in the table shows that the percentage of adults in a country who are currently married is declining. In 1960, 66.7% of adults were married. In 1980, 55.4 were married. In 2000, 52.1. 2010, 43.3. 2012, 41.4. So the first thing says, use the data for 1960 and 2012. So there's 1960, there's 2012 to find the value of K. So let's see, do I know? So here's what I'm going to be solving for is this K. Do I know the end amount? What's the ending amount of the percent of adults married? 41.4, right? That's the end amount. That's the beginning amount. So 41.4. The beginning amount, 66.7. E to the negative K, I don't know the rate, but I do know the number of years that it took for it to go from 66.7 to 2000 or excuse me, 66.7 to 41.4. How many years did it take for that to happen? 52. So the K is what I am looking for. So let's see, I'm eventually going to have to ln both sides since what I'm looking for is in the exponent. But let's first get rid of this 66.7. So now I'm going to have E to the, I'm just going to call this negative 52K. I'm just going to go ahead and multiply that together. Now I'm going to ln both sides. So on the right, I've got ln of 41.4 over 66.7 equals ln of E to the negative 52K. I guess I just shouldn't really have to write that. So since I am ln'ing that side, what does that mean I can now do? Bring down the negative, bring down the exponent. So negative 52K times ln of E, which again is 1. So to get this K by itself, I just need to divide by negative 52. So I'll just put all this in my calculator. Be careful how you put it in. You've got ln 41.4, divide that 66.7. So after you type this in, you're going to close that. And then hit divided by negative 52. And go 4 decimal places. So I've got 0.00917. So if I'm going 4, I need to round that 1 up to a 2. 0.0092 is going to be your K. So that's the first part. Now it says use this answer to come up with the exponential decay model that we'll be able to use for the rest of the questions. So M of T or K of T, however you want to say it. What's the beginning amount? That's always the same, 66.7. E negative, right? Since it's decaying, now plug in your K, which is 0.0092. So that's the second part. So now this is the formula. I'm going to rewrite it up here because this is the formula that I can now use to predict further along in this chart the percentage of adults that are going to be married. Because the next question says, estimate the percent of adults who are married in 2015. So let's see. Now, I know all of this, I need to plug in for this T, which means how many years from the beginning is 2015? How many years is it from 1960 to 2015? 55. So that's going to be the T that you're going to use to predict the percent that are going to be married 55 years after 2015. I mean, after 1960. So again, I'm just going to rewrite this formula that we found. So I am finding M at 55. So 66.7 E to the negative 0.0092 times 55, and put that in your calculator. So 66.7 E, so second ln. In your exponent, you'll have negative 0.0092. Open the parenthesis, 55, close. And we are rounding to one decimal place. So I have 40.21, which means I don't need to round up. So in 2015, there will be 40.2% of adults married. Next question says, okay, what about 2018? So now what's my T going to be? 58. So same thing, just put it in your calculator, 66.7 E to the negative 0.0092, open 58, close, and you're going to round into one decimal place. So let's see, 39.11, which is 39.1. The last question says, at this decay rate, in which year will the percent of adults who are married be 35%? So in other words, now I know this number. It wants to know this year. So I know, let's see, the beginning amount, 66.7. It also tells me the end amount this time. So where the end amount is what comes here. So there is 35% of adults married. 66.7 E to the negative 0.0092 T. T is what I'm looking for, the number of years after 1960. So let's see if I'm solving for what's in the exponent. Let's get rid of the 66.7 first. So now I have E to the negative 0.0092 T. So now I'll ln both sides. Since I'm lning, now I can bring down my exponent. So I have negative 0.0092 T times ln E, and again, ln E is 1. So what's the last step I need to do? Divide by negative 0.0092 on both sides. And this time, we're going to be rounding to the nearest whole number. So I've got ln of 35 over 66.7. Now remember, after you type that in, you're going to close it and then divide by negative 0.0092. Rounding it to the nearest whole number, it's 70.0, which is 70. But that doesn't make sense to put a 70 here, right? What is this 70 telling me? The number of years after 1960. So 1960, 70 years later will be the year 2030. Number 5.
How do you use 7 years? I was getting tripped up on the IE, the alien.
Okay.
issue.
ln 35 divided by 66.7. Now close. Yeah. Now divide that by negative 0.0. Oh, okay, negative. Oh. Uh-oh, is that too big? I don't know what's going on. I can't remember. Something's happening there.
Okay.
So the only thing that needs to, so you'll do ln, it's going to automatically give you an open parenthesis after you type in the ln. And yours actually gives you a closing one too, right?
Mm-hmm.
Yeah. So here's where you want the closing. So in the numerator, you have 35 over 66.7, close, divide that by the negative 0.0092. Okay. All right. Number 5. The number of farms in a certain state has declined continually since 1950. In 1950, there were 85,641 farms. And in 1995, there were 21,717 farms. Assuming the number of farms decreased according to the exponential model, find the value of K, and then write an exponential function that describes the number of farms after T number of years. So we're going to find K. Do I know the end amount? 21,717. Do I know the beginning amount? Yes, 85,641. E to the negative K times how many years did it take to get to from 85,641 to 21,717? 45 years. All right, so let's find the K. So again, divide by 85,641. ln both sides. All right, since I ln the right side, I'm going to bring down the negative 45K times ln of e. Again, that's 1. So now I just need to divide both sides by negative 45. That's going to give me my K. So again, let's divide by, or let's type in first. ln 21,717 divided by 85,641 and close it. Then hit the divided by negative 45 and hit enter. All right, this one is multiple choice. It looks like it's going 3 decimals. Now, here's the difference between the multiple choice and what I'm getting. What I'm getting is positive, and they're saying their K is negative, and that's because it's going to be going down at this rate, right? So point, and it looks like they're going point 3 places. So the K that you're going to be putting into the formula is going to be the negative of this. So your formula is going to be P of T equals, and you'll see this in the multiple choice, P of 0 e to the negative 0.030 t. So your K, you're going to choose the one that says negative 0.030, and then the formula is just putting it in the K position. All right, last one. There are currently 68 million cars in a certain country. $68 million cars in a certain country, decreasing by 1.4%. How many years will it take for this country to have 38 million cars? So this is what it has now. That's the beginning amount. This is going to be your K, your declining rate. 38 million is your end amount. So it's asking how many years did it take to solve for this to happen? So I'm going to be looking for the T. I know everything else. So let's see, I need to know the end amount, which is 38 million, equals the beginning amount, which is 68 million, E, the K is if it's declining at 1.4%, I'm going to have negative 0.014 T. So I'm solving for that T. So once again, I got to divide by 68. Now I have E to the negative 0.014 T, ln both sides. All right. When I ln to the left side, now I can bring down my exponent, negative 0.014 T times ln of E. So now I just need to divide by negative 0.014. And we're going to round it to the nearest year. So let's see, ln of 38 over 68, close, divide by negative 0.014, enter, and the nearest whole number. So 41.5 will round up to 42. So it would take it 42 years to go from 68 million to 38 million if it is declining at 1.4%.